the difference between sequences and series?
An important thing to know when testing for convergence in series is to understand how it is different from a sequence. A series is a summation of all terms of a specific equation, but a sequence is just a list of numbers from a specific equation rather than their sum.
Why does this even matter?
A series converges when the sum of all the terms approaches a finite number. A series diverges when the sum of all the terms approaches infinity. When solving for convergence of a series, it is important to know the parts of the summation sign. The bottom represents what n equals in the very first term, the top represents what the limit goes to, and the equation directly to the right of the sign is your very first term.
The ratio test is a specific test for convergence in which you create an an plus 1 term and an an term, and you create a ratio with these terms and then take a limit to see if they converge or diverge.
Can you show us an example?
The first thing you're going to do is create an an plus 1 term. This means that wherever you see an n in the problem, you're going to add 1. So in this situation, we have n plus 1 all to the third, and then we have 8n plus 3 over 4n plus 2. After this, you take the an plus 1 term and you are going to either divide by the an term or multiply by the reciprocal. They are both the same thing. So my an term is n to the third 8n plus 2 over 4n plus 1. So I'm going to multiply it by the reciprocal. After this, you can simplify this even more and do n plus 1 to the third. And then because your exponents are added, you can separate that into two numbers multiplied together. And you do the same in the denominator. So 4 squared times 4 to the n. And then on the an term, 4 to the n times 4 over n cubed times 8 to the n times 8 squared. Once you reach this step, you can start canceling things out, which is the main objective of the ratio test. So I have 2 4 to the n's. I'm going to cancel out my 8 to the n's. I'm going to cancel out one of the 4's on the bottom with this 4 over here. And I'm going to cancel out 2 of the 8's on top with this 8 squared right here. Then this reduces into 8 n plus 1 to the third over 4 n to the third. Once you reach this point, you're going to take the limit of this ratio, giving this test its name. And you can see already that you're going to use your clowns. So the coefficient, or not the coefficient, but the exponent on the numerator and denominator is both going to be cubed. So you're just going to use their coefficients because of Bosco. And that gives you a limit of 2, which is greater than 1. So therefore, by the ratio test, it diverges.
Wow! I really enjoyed this! Can you show us another one? Really, nerd? Really?
The first step is to identify whether you can use the ratio test or not.
After recognizing if there are exponents or factorials in the term, you need to create a n plus 1 term and an an term. After that, create a ratio of an plus 1 over an.
Take the limit of the ratio of an plus 1 over an. Most of the terms will cancel, that's why the ratio test is so easy.
If the limit of the absolute value of the ratio is below 1, it converges.
Is not necessarily the value that the series converges to.
If the limit of the absolute value of the ratio is 1, it's inconclusive. Try a different test. If the limit of the absolute value of the ratio is more than 1, it diverges. Hit me up if you have any more questions. Until then,